So we're looking at 2017 warm-up number 1. What is the value of 5 minus 5 times 5 plus 5 plus 5? All right, so here we go. Order of operations say that we got to multiply first, so 25 times 25, or 5 times 5 is 25. So we have 5 minus 25 plus 5. Is that plus or divided by? I'm going to look a little bit closer. That is divided by 5. Divided by 5. Division takes precedent over subtraction, so we have 5 minus 25 plus 1. 5 minus 25 is going to be negative 20 plus 1, which is negative 19. All right. How many diagonals are in a convex heptagon? Now, there's an equation that you could use here. But if you don't know the equation, let's go ahead and find a pattern, and then we can talk about the equation later. So if I have n sides and d diagonals, if I have a 4-sided figure, I will have exactly, well, let's even make it easier for us. If I have a 3-sided figure, a triangle, I have 0. If I have a 4-sided figure, I have 2 diagonals. A 5-sided figure will give me 5 diagonals. That's a difference of 2, that's a difference of 3. Let's continue the pattern. So if I have a 6-sided figure, I'll have a difference of 4, that's 9. If I have a 7-sided figure, I'll have a difference of 5, which would give me 14. Now, looking at the equation, if I have a second difference of 1, that means in this I have a quadratic expression because my second difference is constant, and since my second difference is 1, I know that the equation is going to ultimately be divided by 2. So, here we go. So if I'm going to divide by 2, let's multiply. So I have 4, 10, and 18. 4 is 4 times 1. This is 5 times 2. Don't forget, I'm dividing by 2. That's why I'm able to do this. And then I have 6 times 3. Well, this is just the n number. This is the how many side lengths I have, and this number is always minus 3, which makes sense because I can't have a figure that has less than 3 sides. It just wouldn't be a shape. So this is a good equation to know for the number of diagonals in a figure, or you could follow the table. The answer is 14. Okay, what is the first year after 2018 that is a palindrome? Now, a palindrome is a number that is the same backwards and forwards, and palindromes occur in language arts as well. If I have race car, if I read it this way, it's race car. If I read it this way, it is race car. It's a palindrome. So, if I could have 2002, that is a palindrome, but that's already occurred. And I can't have any other palindromes that start with 0, because then that's the only way it works, right? And so I know that I have to start and end with a 2, and so my next option is 2112. I do not think I'm going to be alive for 2112. Just taking a stab in the dark. All right, a standard 52 card deck of playing cards includes 4 aces. What is the probability that 2 cards selected randomly without replacement will both be aces? Express your answer as a common fraction. So there are 4 aces out of 52. And so this is, for those 6th graders, remember, we're looking for the event that we want to happen versus all of the possible events. And so that is getting my first ace. If I get my first ace, then how many aces are remaining in the deck? Well, 3 of them. How many cards are remaining in the deck? 51. So let's multiply these together, and I will get the probability of getting 2 aces in a row. Let me tell you, it's not a good chance. Now, I could just willy-nilly multiply these together, but my goodness, I don't really want to multiply 52 and 51 together. I know, let's reduce. So 4 goes into 52 13 times. So that's 1/13. 3 goes into 51 17 times. Oh, this makes it much better. So I have 1 in, and I have to multiply 13 and 17. So 13 times 17, here we go. 3 times 7 is 21. That's 5, carry the... So it's 1 in 221. Those odds are not good. Not good at all. All right. I really enjoy this next problem. What is the value of the square root of 2 times 3 times 4 times 5 times 6 times 7 times 10? And express your answer in the simplest radical form. Now, you're going to have to fight the urge to multiply those numbers together because, quite frankly, that's going to be a big waste of time. And then you have to reduce it. The best thing is you really want prime factorization. That's right. Remember prime time? That's what we're doing. So I'm going to rewrite this, but I'm going to write it in terms of its prime factorization. So I have the square root of 2, it's already prime factors, times 3 times 2 squared, because 4 is 2 squared. Can you shut the door, please? You can come in, but shut the door. Times 6. Well, 6 is 2 times 3. Shut the door and come. Come on, use your muscles. You can do it, Owen. Oh, nice job. 7, sorry, prime, times 2 times 5. So, no, shut the door. Leave the door shut. You can come in the other door.
It looks so weird.
All right. Sorry for the delay. So how many 2's do I have? I have 1, 2, 3, 4, 5. So I have 2 to the 5th times 3 squared times, well, I have 2 5. Oh, I forgot to write that 5. Oops. I have 2 5's, and I have 1 7. And so I'm square rooting this. So let's deal with these two first. So 3 squared, the square root of 3 squared is just going to be 3. So right now I know already I have 3 times 5, and I can't do anything with the square root of 7. It's just the square root of 7, right? So I still have this. Now let's look at this 2. The square root of 2 to the 5th, that can be expressed as square root of 2 to the 4th times the square root of 2 to the 1st. The square root of 2 to the 4th is simply 2 squared. What is 2 squared? That's right, 2 squared is 4. So I have an additional 4 here, but I still have the square root of 2, which I can't do much with, because the square root of 2 cannot be simplified. So 4 times 3 times 5 is actually equal to 60. 7 times 2 is equal to 14. So I have 60 times the square root of 14. All right, we're almost done here. But since there are students cascading into my room, I will stop and put the rest on another video.